Hey, I'm back. Okay, so I've already taught you how to create a switch for your circuit. So now that you have a switch for your circuit, you can connect a gate to that circuit, and then you will need to create an output LED in order to let you know whether or not your output is a 0 or a 1. Okay, so let me show you how to do that in this video. So the first thing you need to know is that what I have placed on this chip is a 7400 chip, right? So how does a 7400 behave and what does the pinout look like? Let's go find a data sheet and determine that so that as we build, we know what it is that we are looking for. So I am going to put SN 7400 data sheet. All right, and then let's see, let's find one that I like. Let's just look at an image for this situation. Well, let's just look at the data sheet. If we look at the data sheet, we are looking for this one, SN 7400. So we'll just look at this data sheet. Okay, so here's the data sheet. So let's look at, all right, so here's our data sheet. So we are using a DIP package, dual inline purpose. That's this chip right here. Okay, so it says that we can use pins 1 and 2 as inputs and get an output from pin 3. So that is what we'll do. Also, it shows exactly how a NAND gate is supposed to behave. If you put in 2 highs, you get a L, you get a low, okay? If one of your inputs is a low, it doesn't matter what the other one is, you're going to get a high. Same thing here. It doesn't matter what that is. If this is a low, you're going to get a high, okay? So now that we know how it behaves, let's go back to our circuit. All right, so keep in mind that I have powered my circuit with an Arduino chip, okay? So I've used the power supply on the Arduino, and I've connected this side of my circuit board to 5 volts power, and this side of my circuit board to ground. I've already previously assembled my switch circuit. This right here, that is my switch circuit, okay? So now I'm about to add 2 switches to my 7400, and I am about to create an LED output so that I can determine if this gate is working the way it is supposed to. So based on the data sheet, we said that pin 1 was an input, so we will connect pin 1 to switch 1, and pin 2 is an input. We will connect that to switch 4. Doesn't matter which switches we use. I'm just using those because I previously created switches 1 and 4. I hooked them up. All right, now we need an output, right? So our output is pin 3. So we connect pin 3. Okay. But if we don't have an LED, we can't visually tell whether or not our circuit is behaving the way it is supposed to. What we would have to do is take a DMM and measure what voltage output we were getting on pin 3. And if we were getting 0 volts, we would know that would be off. That would be a low. Or if we were getting 5 volts, we know that would be high, or that would be a logical 1. But instead of having to measure with the DMM, we are going to hook up an LED output display for our circuit. All right, so what we're going to do is we're going to take pin 3 and we are going to connect it to an LED and a current limiting resistor. So we're going to make a wire connection just to get it away so that we have room to work over to somewhere else on our board. Okay, remember, we have an LED. You have to connect LEDs the right way or else they don't work. So remember, the long end of the LED is called the anode. The short end is called the cathode. The cathode has to be connected to the current limiting resistor and to ground. So if I pull this out, it looks like this this leg right here looks longer. It is my anode. So I am going to connect it to my yellow wire. Then I'm going to put the other leg anywhere else, doesn't matter. That's my cathode. Then I'm going to connect my cathode to a current limiting resistor. It is 220 ohms. And then I'm just going to put that into ground. All right. Already my LED has come on. Why has my LED come on? Well, because if you look at my switches, input 1 is a 0, input 2 is a 0. So my output should be a 1 for a NAND gate. Okay. Anytime any of the inputs is a 0, the output should be 1. So let's change the first input to a 0, then we have, to a 1, then we have 1, 0, 0. All right, let's try 0, 1. 0, 1. The output should be high. And then if we try 1, 1, this is the only situation where my output should be 0 for a NAND gate. It should be 1 for every other instance except if both of my inputs are high. So this is how you create an LED output display so that you don't have to physically measure the voltage every time.